Between 1969 and 1977, the Apollo mission's instruments recorded about 28 earthquakes on the moon. This finding was a big surprise to scientists. After all, earthquakes on our planet occur due to the movement of tectonic plates, but there are no such plates on the moon. The true cause of the lunar earthquakes has been revealed very recently, and it has simply amazed scientists. What really triggered these moonquakes? And why does this represent a serious apocalyptic threat to us in the future? At first, the researchers thought that the only possible cause of these moonquakes was the impact of meteorites, which are what makes most parts of the satellite shudder. This is the reason why the entire surface of the moon is dotted with craters, which were left by these huge cosmic bodies. However, a significant number of moonquakes can't be attributed to meteorites. This is because some tremors measured up to 5.5 points on the Richter scale. This is pretty high, even for Earth. In order to cause such powerful shockwaves, the falling object would need to have quite a gigantic size. Therefore, scientists had to dig a little deeper to get to the bottom of this issue. Researchers began to carefully study photographs of the lunar surface and compare them with the seismic readings. As it turns out, Earth's satellite is covered with various fissures and cracks. But where these faults come from is a completely different question. Meteorites certainly could not leave such cracks. However, the faults that were discovered are definitely associated with moonquakes. Studies have shown that quake epicenters were 19 miles or 31 kilometers from the faults on average. This is close enough to conclude the cracks are a direct source of moonquakes. Furthermore, 6 out of 8 moonquakes occurred at times when the moon was at its apogee, the most distant point from Earth in the lunar orbit. At this time, the increased gravitational stress worsened the effects of the lunar crust, instigating breaks and moonquakes. So our planet sometimes causes a good shakeup for its satellite. However, the main cause of this problem is not at all in the gravitational interaction with the Earth. As it turns out, it's all about temperature. The inner surface of the moon is gradually cooling. As a result, the satellite has become compressed. Just imagine that the moon is a grape. Then it gradually turns into a raisin. As a result of this contraction, the thin lunar crust bursts and large cracks appear. Then the compression itself is accompanied by very powerful shocks, such as those that seismographs recorded. Therefore, approximately 25% of moonquakes as a result of cooling of the lunar subsurface. These moonquakes represent the greatest danger to the future inhabitants of lunar stations. Just imagine what will happen to astronauts if after a series of jolts, the once safe stations collapsed and people find themselves in disastrous conditions unsuitable for life. To avoid this, NASA scientists plan to place 10 more seismographs on the lunar surface in order to find the calmest areas where tremors are least likely. But the worst thing is not the moonquakes. In fact, indeed due to the cooling and compression, over the past 100 million years, the moon has decreased in diameter by 150 feet or 50 meters. At first glance, it might not seem that, since the moon's size is reduced, it's losing mass. But it is really. Before answering this question, let's first imagine what would happen if the moon did lose at least half of its mass. Then the consequences would be quite significant. Furthermore, if the moon were originally half as heavy, life could not have appeared at all. The fact is that if the moon were only half its original mass, the tidal ebbs and flows would significantly weaken. Tidal waves played an important role in shaping life. They washed carbon compounds away from the coastal zone, which later became the foundation for many of the first living organisms. Even if new life could still emerge, it is unlikely that it would be able to survive for a long time under the conditions created by a moon with reduced mass. A full-fledged satellite maintains the stability of the Earth's axial tilt, but a significantly lighter moon would not be able to accomplish this task. As a result, seasonal temperature fluctuations will begin to change very quickly and abruptly. Ice ages will be alternated with extremely hot periods. Few living creatures are able to adapt to such frequent and harsh changes. And this means only one thing. If the mass of the moon decreases, life on Earth could cease to exist, at least in the form that we know today. Fortunately, this will not happen, because in reality, the compression of the moon does not change its mass. Earth's satellite is slowly becoming denser, but the mass remains the same. But unlike the moon, our planet is actually decreasing in mass. Each year, the Earth loses a total of approximately 50,000 tons. Since the Earth's core consistently consumes energy, this leads to the loss of about 16 tons of mass annually. However, the largest mass leaks are associated with hydrogen and helium. These chemical elements are very light, so they escape Earth's gravity and drift off into space. As a result, up to 95,000 tons of hydrogen and 1,600 tons of helium are lost annually from Earth into space. At first glance, it may seem to you that I'm a bit confused with these numbers here, but in fact, everything is true. Indeed, in addition to mass loss, the Earth also acquires additional mass from space. Approximately 40,000 tons of cosmic dust settles on the Earth's surface throughout the year. So when we subtract the annual loss from the gains, then on average, we net a loss of more than about 50,000 tons. It turns out that at this rate, our planet can theoretically disappear over time. But scientists have assured us that because of the immense size of our planet, this number is rather insignificant. Losses are only equivalent to approximately 1/4,000,000th of 1% of the Earth's mass. It would take trillions of years for our planet to lose all of the hydrogen into space. As you know, Earth is not likely to last that long. Likewise, in fact, the moon will not last until then. But despite the fact the mass of our satellite remains stable so far, the formation of gaps in the moon's crust can theoretically still have an indirect effect on this. According to researchers, cracks on the moon make it easier for mankind to extract minerals. Regolith, or lunar soil, gold, platinum, and many other rare earth elements, such as yttrium, used in the manufacture of computer screens, are all stored in the inner layers of Earth's satellite. Therefore, many see the moon exclusively as a source of valuable resources. Back in 1979, the UN adopted the so-called Moon Treaty, which refers to the policy of strictly peaceful use of the moon's resources. According to this document, mining should be regulated by the international community, taking into account all the opportunities and risks. However, there is one caveat. The agreement was not signed by all countries with the space program. Major players such as China, the United States, and Russia have declared their intention to start mining lunar material in the near future. What methods these countries will use and what consequences the irrational use of lunar resources will lead to, we can only guess. Another threat came from a place where no one had expected it at all. In 2017, one of the smallest countries in Europe, Luxembourg, signed a law of ownership of objects discovered in space. Simply put, if you find it beyond the Earth's atmosphere, it's yours. This small country, with a land area only slightly larger than London, already occupies quite an important position in the space industry. So in the future, we will probably see their flag on the moon. This situation, together with the natural shrinking of our moon, makes us wonder if it's worthwhile to start mining in the very place on which life on our planet depends. What is the likelihood that in the future, due to the active extraction of lunar material and transporting it to Earth, we will make the moon lose its mass? What will happen if we open this Pandora's box? And can we create an artificial moon in case we're not able to avoid an apocalypse? Write in the comments what you think about this. I want to study this topic in more detail and make a video that will answer these questions in the near future. If you like my video, like, subscribe to the channel, click on the bell so you won't miss notifications of new releases, and invite your friends. It's more interesting to discuss